rotation of a line. Yes, you heard that right. If a line in three-dimensional space have direction cosines L, M, N, and if this line is rotated through a very small angle delta theta, and the direction cosines of that same line in the new position is L plus delta L, M plus delta M, and N plus delta N, then how to determine the angle between the two positions of the line delta theta? So today we will see that. But before we start today's video, I want to wish all the viewers of my channel SSD Capsules a very happy and prosperous Merry Christmas. And I would like to request you, if you first come to my channel, please do subscribe to my channel, and if you get really some value from my videos, then like and share these videos with your friends and family. So without wasting any time, let's go to the blackboard. Next page. First we draw the diagrams. Say this is line AB, and if we rotate this line through an angle delta theta, that green line is the new position of the same line AB. So we name that. Say this is point A, this is point B, and AB, line AB is rotated through a small angle delta theta, and AB dash is the new position of the line, and it is given in the question that element are the direction cosines, not ratios. Just notice that element are the direction cosines of the line in position AB, and here L plus delta L, M plus delta M, and N plus delta N are the direction cosines of the same line AB in its new position AB dash after rotating a small angle delta theta. So how to determine the angle delta theta and to prove the relation like that? So here we will use the concepts what we have discussed in our earlier lectures, that the relation between the direction cosines may be lecture number 2 or 3. You just check the playlist section of my channel SSD Capsules. L square plus n square equal to 1. That concept we are going to use, and angle between two lines. See that lecture named as angle between two lines. So these two concepts we are going to use today. So here, okay, as delta theta is the angle between the line in two positions, in space. Therefore, cos delta theta equal to actually angle between them. What is the formula? A1 A2 plus B1 B2 plus C1 C2 by root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. But here element and L plus delta M, M plus delta M, and N plus delta M are direction cosines. So the denominator part will become 1. So we just simply write L into L plus delta L, M into M plus delta M plus N into N plus delta N equal to L square plus M square plus N square plus L delta L plus L delta M plus N delta N. So here relation between the direction cosines L square plus M square plus N square is 1 into L delta L plus M delta M plus N delta N. So here we have in our hand, next page, therefore L delta L plus M delta M plus N delta N equal to, see previous page, cos del theta minus 1, cos of del theta minus 1. Now here the direction cosines of the same line in its new position AB dash are this. So again we are going to use the relation between the direction cosines of a line, that is L plus delta L whole square plus M plus delta N. Now L plus delta L whole square plus M plus delta M whole square plus N plus delta N whole square equal to 1. Okay, so implies L square plus M square plus N square plus here delta L square. We just evaluate the values of these whole squares. Okay, delta M square plus delta N square plus 2 into L delta L plus M delta M plus N delta N equal to what? Equal to 1. So here implies 1 plus delta L square plus delta M square plus delta N square plus 2 into L delta L plus M delta N plus N delta N equal to 1. So now we just simply put the value of L delta L, M delta M and N delta N here in that relation. So name this as 1 using the relation 1. We have, see previous page, 1 plus delta L square delta M square plus delta N square, see previous page, plus 2 into here L delta L plus M delta M plus L delta N equal to cos del theta minus 1. Cos del theta minus 1 equal to 1. That 1 will be cancelled out from both sides, right? So implies delta L square plus delta M square plus delta N square equal to, if we take this term to the right hand side, it becomes minus 2 into cos delta theta minus 1. Implies delta L square plus delta M square plus delta N square equal to 2 into 1 minus cos of delta theta. Now we will use the formula that 2 sin square theta by 2 equal to 1 minus cos theta, that we are going to use here. So here 1 minus cos del theta means 2 sin square del theta by 2. So next page. So now delta L square plus delta M square plus delta N square equal to, see previous page, 2 into 2 4 sin delta theta by 2 whole square, right? Yes. So now we also know that from differential calculus limit chapter, limit theta tends to 0, sin theta equal to theta. That is, if the value of theta is very small, then value of sin theta is equal to theta. Here also in the question it is given that the line is rotated through a small angle delta theta. That is, the angle delta theta is very small. So we just can write by this, we can write sine of delta theta by 2 equal to actually delta theta by 2. So here delta L square plus delta M square plus delta N square equal to 4 into, here sine delta theta by 2 means delta theta by 2, so delta theta by 2 whole square implies here delta L square plus delta M square plus delta N square equal to 4 into delta theta whole square by 4. So 4 will be cancelled out. So we have reached to the end of today's video, that is delta theta square equal to delta L square plus delta M square plus delta N square. We have proved that relation. So here therefore we have delta theta square equal to delta L square plus delta M square plus delta N square. That is our desired condition. So proved. So hope you have enjoyed today's video. This problem is taken from this book Ncert Exemplar Problems for class 12, and this problem is very much important for CBSE 12 board exams and KVS NVS teacher recruitment exams also. So hope you have enjoyed today's video. If you really get some value from this video, please do subscribe to my channel and like this video and share this video with your friends and family. Thank you for watching.